Hi. Do you have any questions about the previous classes or something? And our plan today is like the Q&A part and the following parts: Python visualization, and the distance. What is distance, and what is the clustering? Thank you. Maybe we can just start today's topic, and if you have any questions, you can tap them in the chat box or submit them in the Google link. Let me share the link. So today, let's talk about how to plot the figures by using Python. Does Python doesn't provide such direct functions like R to plot your figures, but you have to apply another package, and this like this. This is this one, matplot library. This is a popular package. You can plot a lot of figures using this one. It gives you the examples, the bar plot, line, and so many. I think this, if you want to use Python to do such kind of visualization tasks, I believe this is a great and enough package for you. So let me show you how to start it. For example, we have the x-axis data 0 to 4, and the y-axis data 10 to 50. So use this. Do you remember this is kind of a way to import the package? We can just use this short tab instead of the long tab. So just use plt.plot to plot this. Put the axis data here and the y-axis data here. And set the title name, the X labels, like here. X labels, some numbers, Y labels, any numbers. And to show the figure, use the plt.show, you can get this result, this figure. And if you want to save it, just use plt.save fig and figure name. PNG or PDF. This is another style of the visualization. If you want to plot the points, you can use this parameter. R means right, O means a circle. So if you want to plot a right circle, just add this parameter here. And of course, you can like use this one, blue circle, or let's see. Use a blue square. See? And this shows you how to plot multiple lines in just one canvas here. Like here, the first line is right circle, second is blue square, third is green triangle. So here we can plot 3 lines. The same thing here, we can plot the right line, blue line, gray line. But if sometimes we need both the points and the line. This use this parameter line style. The first line style is a dot, and second is line. For third is 2 line, and they are here in their official website. You can see so many line styles like solid, dotted. You can use it, and also it provides examples to show you how to use these line styles. So if you want to optimize your figure, you can go to here to choose the line style you like. This is another example for the hist. Just use the plt.hist function to plot this kind of figure. The face color means the color of this bar, and the edge color is the color of the edge. Title is HIST, and set your X label, your Y label. Maybe sometimes if you want to do your Python project, you may need this kind of figures to show your results in your like project report. So the visualization is, I think is an important part. This is a pie plot. Then the label list is 1, 2, 3 to label each part of your pot of your pie, and red, green, and blue. The size means the percentage of each part. This legend you can see 1, 2, 3 for each the color to label the pie, to help others to understand it. If you want to put several figures in just one canvas, you can use this example. So, for example, T1 is your first data side, first data, and T2 is your second data. The package NumPy is a very, very useful and very, very important data science package. It provides very many functions to help you analyze your data. So just to plot the first subplot here. 3 means you have 3 figures in one canvas. And 1, 1 means the position. The first row, first column. And the second means the first row and the second column, first row and third column. Oh, sorry. Third row, first column. O means dot. So you can put 3 figures in one canvas. And then there is another example to show you how to put 4 figures. The same data. And the parameter here means 2, 2 means you have 2 rows, 2 columns figure. 1 means the first one. 2 means the second one, and 3 means the third one. 4 means the fourth one. If you want to put more figures in one such big canvas, you can change the parameter here. Like you want to like a three rows and 3 columns. 1, 1 to 9. The last one to arrange your figures. Also, if this kind of like this scatter, this line or the pie or the bar is not enough, are not enough for you to show your results, you can just go to this link. This link to see more examples. I believe you can get a good one. because today we don't have enough time to tell you all of these kind of figures. I can just tell you how to use them by several examples. Then let me say what is distance. A popular distance formula is called the Euclidean distance. This is its equation. And for example, we can just say this figure. For example, you have 2 points. The first one is -2, 2, and the second point is 2 and -1. You want to know their distance. This is called Euclidean distance. You can use this equation to do it. But we want to realize it in Python. This is the example. First, the first point to, let me see, -2. Oh yeah. First point is 2, -1, and another is -2 and 2. Same there. So this line shows you how to realize this basic formulation, this formula. The square of the sum of the square of the residue. The first 2 minus -2 and power 2 plus -1 minus 2 and power 2. You can get the Euclidean distance. So it's 5 and 5. This is called a Euclidean distance. One thing I need to mention is that in Python, you cannot minus to list. For example, here we want to know the answer or the output. The output is 1 minus 1, 2 minus 1, or 3 minus 2. It should be 1, 1, 1. But if we just data 1 minus data 2, we can get the type error because the minus is unsupported. And what if we want to add them? In the real world, we may think is the answer of the data 1 plus data 2 is 1, 1 plus 0 is 1, 2 plus 1 is 3, and 3 plus 2 is 5. So we may think the answer is 1, 3, 5. But in Python, if you want to add 2 lists, you just link them, not add them like not the sum of each of them. So it's 1, 2, 3, and 0, 1, 2. But a Numpy array is like the list, but this Numpy array provides more operations. Like here, the data 1 is 1, 2, 3, and then we convert the Python list data 1 to a NumPy array. And the data 2, this is a Python list 0, 1, 2. We also convert this data 2, list data 2 to NumPy array. Let's say we use data 1 minus data 2, we can get 1, 1, 1. And add them, data 1 plus data 2, we can get 1, 3, 5. So pay attention on this difference. And if you have to precise like vectors or matrix, please use data NumPy more. Let's go to the next distance. It's called a Manhattan distance. Manhattan distance is also called the city block distance. For example, each right block here is it's a city block. So if we this point to this point, their distance, their Euclidean distance is the green line. Use this formula to compute the length of this green line. This is Euclidean distance, but this red line and the blue line is called Manhattan distance. The sum of their absolute values. Let's see how to realize it in Python. See, we have the same points x1 and y1 to -1 and -2 and 2. So first, ABS is a Python built-in function to get the absolute value. Let me show you. ABS x1 minus y1 of ABS. It's a 4 and a 3. 2 minus -2 and -1 minus 2 is 2 and 3. And the sum of these absolute values. 7 is Manhattan distance. Another distance is called a cosine similarity. It's also called cosine distance. This is, for example, you have a 2 vector. This is the first one, the second one. This formula shows how to get their theta, their angle here. and their similarity by using uh, your first point, your first vector, or your first point A dot your second dot product your second vector B and divided by the production of their norm. The norm here means Euclidean distance. It's also called Euclidean distance. If we want to realize it in Python, say same point x1 and y1 dot production x1 and y1. So norm x1 times norm y1. This is their cosine similarities. Not just these three kinds of distance formulas. We have so many distance types. If you want to know more types of distance, you can go to this link. It tells you the Minkowski distance, this formula, Manhattan distance, Euclidean distance, high mean distance. How to select one distance to use this depends on your 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 project or your like for example, if you have a if you want to know the distance between like apartment B and apartment A, I don't think you can go to B from A just like this. If you want to go to B, apartment B from apartment A, you have to, you can't, I believe you can't just uh, walk like this, just across the buildings. You have to follow the right lane or this green lane. Like if you are using Google Map, it shows you this kind of distance. But sometimes if you just want to know, like this city to the, let me see, city A to city B, you just want to know the closest distance. You don't care how to go to there. Just want to know their distance. You can use Euclidean distance. Usually, you don't need to write or to realize the distance by yourself, like this, like this or this. There are so many useful packages in Python to help you calculate the distance, like this SAIPY package. It has a distance function to give you a lot of kind of distance directly. Like, let's see. This SAIPY spatial distance give you the example of usage, the parameters pdist, pairwise distance between observations. Here, this is cosine distance, Euclidean distance, and the city block means the Manhattan distance. So many different types of distance you can use. If we run this cell, we can get the same points, x1 and x2. So its Euclidean distance is 5, and the cosine similarity is 1.9, and the Manhattan distance is 7. There are differences. I don't know what happened. Sometimes we use different types of distance to do the clustering job, clustering tasks. What is clustering? For example, you have these points, yellow one, yellow, green, or red. If I allow you to classify them by the color, it is very easy. You can just put the yellow points here and put the blue points here and put the red points here. So this is a type of clustering task based on their color. But in real world, we barely use the color to classify your data. Most of the time we use distance. This is called a cluster. This is called a clustering step. And one, this is a cluster. This is another cluster, and a third cluster. To classify the points or the data you have, or you can just to split them. This is a kind of clustering mission. And the k-means is a very useful and fast clustering method to help you classify your points. For example, you have these points. Firstly, at the beginning you don't know their labels, or you don't know this point belongs to which cluster, and you can do a k-means to get your clusters. Usually, k-means is based on the Euclidean distance. See, the points in this cluster, they have the minimum, they have the minimum Euclidean distance. And the same thing, this one and this one. This block shows you the details, each step, all the steps of this k-means cluster, this k-means algorithm. So if you are interested in k-means, please read this later. Today, I just show you an example how to realize k-means by a third package. It's called sklearn. This sklearn is very, very useful machine learning or statistical package in Python. And do remember this PLT to plot your points. Let's see. There is an example to show you how to use this k-means. So just first import from sklearn.cluster, import k-means. K-means means the function number, and import numpy as np. Then you can use this short term instead of this long term. If your input data is like this 1 2 1 4 1 0, it has let me see, 6 rows and 2 columns. The first one, you can think the first 1 1 1, it's the x-axis values 10 10, and 2 4 0 are the y-axis values. Then you can plot a 2D figure. So how to call this function? Just the k-means, and n clusters means we need 2 clusters. Random state, you can just ignore this. I don't means the initial position. And to fit this your inputs, you can get all the results, like its labels, centers. Let's run it on our own data set. For example, we have a data 1, which is 100 points. From normal distribution. And the data 2, normal distribution, but a +4 here means to move the mean of these random numbers. Let me show you. What it looks like. See, these are the points belongs to data 1, and points data 2. The mean, mean center, or the center, the mean of these points are 0. So 0, 0, and the mean of your second data is 4, 4. And if we run the k-means clustering method on this data, Let's see. Oh, here we need to band the data by row. V-stick means band the data by row. Well, I can just print the data. Let's data one. Say this is data one. Data one, 100 rows and 2 columns. And data two, to say its original data to make you understand it better. See. And data raw band. Here we have 200 points or 200 rows and 2 columns. Let's run it. See, k-means can separate the 200 points by the Euclidean distance. The first cluster and the second cluster. If we need 3 clusters, we know the truth is that we only have 2 clusters. But if set the number of clusters is 3, let's see what can happen. See, the k-means just to give you 3 clusters. This one, this, and this. Also by the Euclidean distance. And this is 4. Four clusters, yellow, green, I believe this black or dark blue. So you can say one shortcoming here is that you have to know the number of clusters to get a very accurate result. And of course, there are so many ways to help you how to decide this number here. This function, plt.scalar, to plot this kind of scalar plot, scalar figure. The first is x, and the second is y values. So say means color. And here I need to say that the k-means result, not just to store the labels. Let's see. K-means results dot cluster centers. Say around 4.9. This is center or is mean. The mean of this cluster or the center point is 3.9 and 4.0. and the center point of this cluster is negative 0 and 0. Also, it gives you the credit labels. One here means this k-means classifies the first point is label 1, or the first cluster, and the second point belongs to the also first the first cluster. This called labels. K-means is just a popular choice or a popular clustering methods. There are so many clustering methods. This is an overview of the clustering methods, and all of these methods are provided by sklearn.cluster. You can use this package to use all of these clustering methods. Here it shows you the results. And how to use each of them. K-means, and another shortcoming of k-means is that your data shape has to be a circle like this. If you have a weird shape like this, you cannot get the correct answer. Like it should be. This is the cluster 1, cluster 2, and cluster 3. But it k-means cannot give you the correct answer of this kind of data shape. But others can. For example, this one, you have two clusters. And the spectral clustering give you the correct cluster results. First circle, second circle, the first half circle, and the second one. Let's say here, spectral clustering outputs the correct cluster results. First green, blue, and orange, but k-means cannot. See. You may use Python to do your project. Just suppose here, this data 1, data 2, or this data raw band is your gene data. Suppose this is your gene data. Sometimes you may need to classify them. This is the reason I tell you this clustering methods today. And you can use maybe your gene data has 100 rows, maybe 200 columns, but you cannot plot them. For example, you have your gene data. It has 100 rows. The first gene data has 100 rows, 200 columns, and the second one, their row combined has 200 rows and 200 columns. And if you wanted to classify the genes, you can use this k-means. And if we see the label, we can see, for example, gene 1 in cluster 1, gene 2 in cluster 1, and all these first 100 genes in cluster 1 and the others in cluster 2. Sometimes you may need other distance, like let's say if we want to use cosine distance to classify your gene data, maybe this is gene data 1. Oh, maybe I use this. The input must be a vector. Let's try this. Oh, I don't know what happened. This is I must use like the row column. Zero raw. So you can get the cosine distance uh, between the first gene and the second gene. Sometimes you may make mistakes when you do the coding things, like for example here I forgot zero here. It shows you the syntax error, and we need to locate the error and get the reason and correct it. This is called debug. Bug here means an error. Like here, it shows the syntax error, invalid syntax. So we need to say, oh, what happened? Or let's say, oh, here, let's go to here. Oh, I know, there we last one. We need 1 0 here. Then we get the correct answer. This process is called debug. If we need all the cosine similarities, use this one. Get all the pair of in range 100. And I here. See, we can get all of the cosine distance, cosine similarities. And we can use this distance to do. Oh yeah, please. Let's over here. We may have to go to another meeting. Thank you. Have a good day. I will upload this later.